we alone in the universe? This is one of the greatest questions. Humanity is on a mission to find that answer, and it could forever change how we see the universe and ourselves. OHB Group is a group of companies with its headquarters in Germany. We are building large and complex space systems for the European Space Agency, European Union, and European governments. This site here in Oberpfaffenhofen, next to Munich, is our Center for Science and Optic Missions. For the European Space Agency, we create for the PLATO mission the spacecraft, and for the ExoMars mission, the gas trace orbiter and parts of the rover.
PLATO is made to look for habitable planets. So it's made essentially to answer to the question, is there life out there? We know life would most likely exist on rocky planets in the right distance from a sun-like star, so liquid water can exist. The way that PLATO finds planets is by observing the dip of the planetary transition in the light before the star. It will observe around 1 million stars up to 6,500 light years away with 24 cameras and 2 cameras for guidance. The challenge in building satellites is that we typically build 1 or 2 of them, and they need to work the first time and throughout the entire mission. PLATO has to have the utmost precision of the alignment between the cameras and its stability. As a comparison, it needs to be stable enough to capture the diameter of a dime at the distance of several hundred kilometers. And now before that, it has gone through a launch, and certain elements exhibit up to 50 g accelerations, and then in space are exposed to thermal conditions between minus 150 and plus 150 degrees C.
So the topic of metrology, which means to measure the dimensions of parts with very high accuracy, is a fundamental aspect for building instruments and optical systems for space applications. We typically measure distances from micrometers up to several meters, and for this we need a whole bunch of measurement devices from Hexagon, such as laser trackers, CMM machines, and software. For PLATO, the alignment of the instrument and the satellite is done by laser tracker systems. Every subsystem has dedicated points, and we measure the position to a global system with extreme accuracy. Now for the cameras, they must be identical and perfectly aligned. But an optical system with 0 tolerances, this is not realistic. The solution is to add sub-micrometer shims between interfaces until we get from the CMM the ideal performance. Then we measure the shims and manufacture an additive exactly for this interface. But this process came with a challenge that we have to operate the Hexagon machine inside of a clean room. So they helped us customize the CMM, materials used, grease and glue. So now we can operate in an ISO 5 clean room and even below.
Micron-level precision in metrology is also needed to build the instruments that detect life on Mars. And for that, we are building a crushing station for the ExoMars rover with the mission to detect life. It will drill the surface of Mars, collect samples, and the crushing station produces a powder from these samples that can be analyzed by an onboard laboratory. For us, specifically, computer tomography or 3D non-destructive testing is critical in order to be able to assess the wear and damage in a system that we don't disassemble.
Traditionally, we build something, we test it, and then disassemble the mechanism and look for the single parts. But if you disassemble a gearbox, you can assemble it again, but it will not be absolutely the same. So, we analyze our non-destructive testing with Hexagon VG Studio Max, and it is opening an outstanding opportunity accelerating our process. Another example is PLATO. There, we are also responsible for assembling and soldering electronics and computer chips. In space, the thermal expansion and contraction is creating a lot of force and potentially damages on the soldering joints. With computer tomography, I can see the evolution of a crack getting larger until I can make a decision. And by this, we can optimize now our solder procedure. We can predict it. And this is reducing tremendously meetings, clarifications, and time needed.
The quality of the data from Hexagon's technologies is fundamental for the success of our space missions.
I have used Hexagon for precision optical instruments for more than 30 years.
With Hexagon, we found the ideal partner that is just a phone call away, and we have the right team supporting us.
I believe strongly that there is life out there, just because the likelihood would be so incredible that we are alone.
If there is life on other planets, with ExoMars and PLATO, we think that we come a step closer to answering this question.